So in a previous video, we've looked at this definition of the radius of convergence, which is something you would have studied before in Calc 2 or wherever you might have studied it. But in this video, we're going to actually look at why and how do we use the radius of convergence. So let's get into that. So I want you to recall this example we had done earlier in the power series method, where we solved this differential equation and the solution turned out to be this exponential function. Now imagine that if we didn't have this, so this basically would indicate that we would have to, what I mean is basically the following. Suppose that we didn't know that the power series actually was this exponential, and we had to leave the answer at this point. We cannot just do that. We need to test that this power series has a radius of convergence, because the validity of the solution, it's only as valid as the radius of convergence. So if we were to apply the radius of convergence to this particular example, what would happen is the following. So we would just basically, this is your nth term essentially, and you just do the Cn over Cn plus 1. So let's see what that gives us. So it would mean that, so this would be rho, so that's the nth term and that's the n plus 1th term. And of course we can see a lot of cancellations going on here. Clearly the minus 1 to the n and the minus 1, one of them, only one will remain. So that's gone essentially. And the 2n goes away and leaves us with just a 2. The C0 cancels, and we have basically, this is upside down, so the n factorial will cancel and leave us with just n plus 1 essentially. So this is just going to be equal to, so equals n goes to infinity, n plus 1 over 2 goes to infinity, and an infinite radius of convergence. As you can see, this is category C, which means that the series converges for all x. And that's what actually happens in this case, because as we know, the Maclaurin series in fact converges to C0 e to the minus 2x. So, but please keep in mind that it is possible for this power series to not converge, or to converge for very few values. In that case, if the values aren't of interest or are outside the domain of interest, then this solution is not a viable solution to the differential equation you're interested in. However, the other important thing you need to keep in mind is that this solution that you see here, this basically this solution, okay, this is quite important in the sense that you know, at the end of the day, if you don't recognize this as a known Maclaurin series, for instance, or a Taylor series, then it is necessary, in fact, to calculate the radius of convergence to try to figure out how useful the solution actually is. So that's basically the idea of the radius of convergence. So that's it. We'll stop here. Thank you so much.